Okay, part 2 of day 1 on these related rates. We were working with this cone, and I rewrote some of my information so that I could just get it a little bit more organized. And then I noticed I made a mistake here. It says how fast is the water level rising, which would be dH dt. That's what we're trying to find, no problem with that, when it is 10 or 15 centimeters deep. I wrote down that R would be 10, but that's not true. If we want the depth, we're talking about the height of the cone. And that means that we're looking for H. And you know what? The numbers will work out better if we change 10. Let's change it to 12. I think that'll make some nicer numbers for us. All right, then I went over and I've got this sketch of the cone. The actual cone, we have to take note of this given information here too. It has a height of 16 and a radius of 4. That's the structure of the cone. As we fill this thing, let's say this is our water level right now. It's going to have a height of H and a radius of R that continually changes as that rises. So if I took dV dt right now and do the derivative to get dV dt, I would have to do the product rule on this because I have an R and an H multiplied by each other, both variables. And that would lead me into dr dt and a dH dt involved, as well as a dV dt. Nothing wrong with that, but we can make our life a little bit easier if we solve for one of these variables. And the one we're going to want to solve for is R. Let's put radius in terms of height. And then I'll have all H's here, some sort of H times H. What does that H look like? Well, we come back to our picture and we notice that if I did a little cutaway of this cone, I would have similar triangles. So this inside triangle here would have a height of H and a radius of R, where the outer triangle, the larger triangle, has a 4 and a 16. Well, these two triangles, the large triangle with this nested inside one, are similar triangles. So we can go with similarity to solve for one of these variables. So more geometric comparison work. So I'm going to say 4 is to 16, the outer triangle, compares like R is to H. And we said we want to replace R up here, so let's solve for R. If I solve for R, I'm going to multiply by H. I'm going to have H times 4 over 16 equals my R, which that implies then that R is a fourth of the height, basically. Okay. Now, when the height is 12, we would know what R is if we wanted to, but we don't have to go back to that. So, I shouldn't even mention that. Let's go up and do our derivative. Substitute in that R expression. R is equal to 1/4 H, getting squared, times H. All I did was replaced R with 1/4 H. Before I take the derivative, I wanted to get this this down to just two variables. It'll make life a little easier. Square out the 1/4, and we're going to have 1/16. Square out the H, we're at H squared times H. Keep updating. This will be pi over 48 H cubed. Now we are ready to do the derivative. The derivative work. dV dt is equal to pi over 48, just a nice multiplier, 3h squared dH dt. Very nice. Now let's substitute things in. We knew dV dt was equal to 2 centimeters, or 2 cubic centimeters. So 2 is equal to pi over 48 multiplied by 3, and then our H, we know that. We said let's let H be 12, and that is going to get squared, and then dH dt. I know that 3 goes into 48 16 times, So I just keep updating here. I'm going to be at 2 equals pi over 16 times 144 dH dt. 16 goes into 144 9 times. So we will have 2 equals 9 pi dH dt, and now just solve for dH dt. dH dt is equal to 2 divided by 9 pi. And there is our solution. Labels would be, height would be in terms of centimeters, and then time was in minutes, I believe. Yep. And there's our answer. Tomorrow we will work on the homework in class, and that will be our homework assignment. Have a good day.